Children, um, and it's good to be with you again this morning. My name is Mr. A.F. Gabriel, and once again, welcome to this very special holiday program in conjunction with the Department of Basic Education and Africa Teen Geeks, and it's called Robotics and Coding. I'm your facilitator, Mr. A.F. Gabriel. This is the third session that we've had since the program has begun. And I'm also not going to waste too much of time, but just if anybody has joined us for the first time, I'm going to quickly just recap what we have been doing and what everything is all about so far. Okay, now, we have been teaching you about something called coding and robotics, in which case we want to teach you how to write what we call computer code to be able to communicate with an electronic device. And when I taught you on the first day, I give you the example of a remote control, a radio remote control that is controlling a car. And when you press certain buttons, the car responds. Somebody has to write the programs that is sitting on that remote control, and that is what we do as coders or programmers. Now, I want to again remind you of an important word that I also taught you on in Monday's first class, and that word is algorithm. And the word algorithm, and if I'm just going to remind you very quickly, the word algorithm, and I'm just looking for that slide in which I had it on. Here we are. The word you're seeing on your screen now is the word algorithm, and it's pronounced like so, rhythm. And an algorithm is actually a series of instructions that we have to write up in a programming language in order for an electronic device to be able to respond or understand what we are wanting it to do. Now, remember, we speak English and our language, well, in this lesson, but you number of languages which you use for communication. Electronic devices, we can say, let's say they speak digital. So we have to be able to study a language that we can use to instruct this electronic device. There are lots and lots of languages that can be used. I think you might have heard of some like Java and Delphi and Pascal. And of course, if this program becomes successful in your school, you will probably be using Python when you get to high school. But here to teach you, Python may be a bit too complex to begin at your level. And so we want to teach you how to use a language of instruction that is a little bit easier to work with than Python. And now we're going to go to what we looked at yesterday, where I introduced you to MS Zora. Now I'm just trying to open my browser here. We are going to go to the MS Zora website. And if you remember yesterday, I told you we type mszora.co.za in your browser, whatever browser you're using, and you press enter, and your computer will take you into the MS Zora page. So what you should be seeing on your screen now is your MS Zora homepage. Again, yesterday I went through the process of how to sign up. Remember, if you are using MS Zora for the first time, you will have to click here to sign up. And I'm not going to go through the process again, but just again, in case somebody just joined us for the first time, you can look at yesterday's recording in which we uploaded to YouTube, and it will go through this process of how to create an account. If you haven't created it, you have to fill out this page and create your account. And then once your account is created, you can log in. During the sign up, you will have to give yourself a username and a password and so on. Again, you can see that my username and password is set to be saved in my browser. You click login, and as soon as you do that, it will open up on the web page, and you will find your what they call your dashboard. Don't worry too much about that word right now. We'll go into more detail about what a dashboard is later on when we get to use the dashboard. Now, MS Zora is what we call a block-based programming language, in which it's very easy. It's like working with Lego. Lego is already pre-created. All the blocks are pre-designed by the Lego designers, and you simply have to fit them together in order to create something. And sometimes Lego blocks come with those little instruction booklets which tell you how to put certain blocks together in a certain way to get a specific type of design in the end, like a tractor or a car or a helicopter. So what you are doing when you're looking at that page is you are following an algorithm. The Lego designers have placed an algorithm in their booklet, and if you follow those steps, in the end you can use the Lego blocks, put them together, and you can make something. Now right here, using MS Zora, it's the same idea. We have these blocks that you will have to learn how to use, of course, and once you learn how to use them, you can put them together in a certain way, and you can create a specific project. And that project will, in this case, is going to give instructions to this guy out here, which again, for those people who have just joined us for the first time today, that's called a sprite. Okay, now, again, I'm going to go quickly. I've already done this yesterday. This is the screen where we're going to be doing our programming. And this is the screen where all the blocks are. This is the color coding for each of the blocks, which is put into groups so that you can find the blocks. Can you see there's lots of blocks? Imagine if they were all mixed up and we were trying to find particular blocks. It would be very difficult, and it'd take us a long time to find things. Okay, so these are your blocks. You choose them and you drag them into this area. We'll do that in a moment. And so you can look at your program code. This is called your script area. On the right hand side where my mouse is now is your stage. This whole place is called the stage. And the instructions you are giving to now, I said normally we'll be talking about robotics, but in this particular program, these things that will be following our code instructions are called sprites. So this guy is sprite 1, and you can see you can name him, but we won't do all that right now. But for now, let's just call him sprite 1. And you can see that on the stage, before you write anything, you can move the sprite around wherever you want to, and you can do a few things with him. For example, here is the sprite control area, and if we wanted to, for example, if we feel he's a little bit too big, you can see there's a size window there, and that's a percentage, so that's 100% of his size at the moment. If I go 80 and press enter, can you see he's got a little bit smaller? And that is because I have reduced him to 80% of his original size. Okay, if he's facing forward, and that direction is 90 degrees. Now you can see if you click there, it gives you this little clock-like thing, and 90 degrees is at 3 o'clock. And if you go to 6 o'clock, okay, he's going out the window there. If we go to 6 o'clock, you'll find that you'll turn the sprite in that direction. And you can see he pivots not on his feet, but in a central area there, right? And we can take him this way. Oops, let's put him a little bit lower. So when he turns, it's not so out of our screen. And of course, now he is at 12 o'clock. And of course, now at 90 degrees, he is back to the 3 o'clock position, which is facing forward. So you can, mess around with your sprite in any way you want before you started writing. We haven't done any code yet, so we're just kind of setting the sprite up. Okay, and of course, you'll see some X and Y values there at the bottom. Okay, I was going to talk about that later, but let's do that quickly. Okay, I'm going to move the sprite on the screen. I want you to watch this X value, which is sitting at -209, and the Y value of 142. I'm going to take the sprite and I'm going to drag him forward a little bit. Okay, now you'll find that the X value has dropped from -200 and whatever it was. Now it is -60. The Y value is still the same, 142. And all I did was move him forward. Now I'm going to leave him here where he is at minus 60, and I'm going to move him up a little bit. And let's have a look. Oh, I'm moving him too much. And now let's see, well, look at the Y value. It's increased all the way up to 234, and the X number is still minus 60. Okay, now, does anybody want to guess what those two values do? Anybody? You can just raise your hand if you want to answer. Okay. I'm talking to Libuseng. Am I right?
Yes, hi sir.
Hello, how
My
are you?
name, I'm good, and you?
Yes, yes. You can probably just give your name so everybody can hear you.
My name is Tapa, my actual name.
Okay.
I'm 12 and I live in Joburg.
All right.
To
Well,
answer your question,
yes, to answer my question.
the X and the Y tell us in which position vertically and horizontally the sprite is standing.
Excellent. Well done. Thank you so much. That is the correct answer.
Thank
I
you.
think everybody heard that. So well done to you. You've answered that question correctly. Okay, so those are the X and Y coordinates. Now, here's the thing. I don't know why the numbers are so terrible. I can't really, that's how the program is designed. Like you'd expect it to start from 0, but if you put the sprite all the way on the corner of the screen, you'll see like the X value goes to minus 284 and the Y value is 132. And of course, as you go this way, the X values start to get bigger, right? Remember, a highly negative, that's minus 132, and that's minus 67. Minus 67 is a bigger number than minus 148, right? So the X values start to increase. And if you take them like past this point here, you'll see they start to get positive. Now it's 52, 71, and on the edge of the screen, it's like 189, seems to be going like towards 200. The Y values get bigger as you go up, 209, 241, now it's 270. And as you go down, it starts to get smaller, it's 16, and like now it's like minus 32, right? Okay, so we're gonna use these X and Y values at some point in our coding. Whether we'll get to that point today or not, I'm not too sure. But we'll see how much we can go. But I'm sure you're all excited to actually start writing some code now, right? Enough with these fiddling and the introductions and all of this stuff. Okay, and I'm sure some of you might have been playing around with the with this yesterday after our class yesterday. Okay, so what I'm going to do now is I'm going to start showing you how to create a program. Well, a script, right? We'll call it a script. Okay, now first, before we begin, I want to, I did say this to you yesterday. This green flag is a go flag, and this is our stop button. At any time, we can press the stop button to stop running a script. Sometimes maybe something is going wrong. And let me tell you, you can also, if you have errors in your code, you can have a code that doesn't stop running, it gets stuck. So when it does get stuck, we will click the stop button to stop the code. This is usually, sometimes you can click on a code block to run it, but most of the time we will press this button here to now indicate, it's like let's think of it like an on switch. You can switch your device on and then the sprite will receive your instructions, right? But we also have to tell the computer that the sprite is waiting for the flag. So I'm going to take you to the control section, or sorry, the event section. Okay, now again, I did remind you yesterday to have a notebook with you because yes, you'll have the recording for this, but if you make some notes also, I feel it's much easier to work from notes than the recording. And then you can, use your little notebook, have it on your table, and then you can start experimenting with everything that we've learned today. Okay, so we're gonna put our first piece of code block into our script window. Yay, very exciting, right? Okay, so if you look at this very first event that's on our list, right? And don't worry about all the events. They might seem very confusing to you right now, but we'll start to learn events as we need them, okay? And of course, by all means, experiment if you want to. So I'm going to introduce you to one event now. This is called when the green flag is clicked. Can you see that? So what do we do when we want to use one of the blocks? We simply take the block and we drag it into the script window, okay, with your mouse. So you drag, you hold it down. Let's put it back. Okay, so you can see this grab hand. The pointer changes from a pointer to a grab hand so that you can grab the block. I'm holding my mouse pointer. Can you see the hand is now in that grab mode? And you keep the mouse pointer down as you drag it. If you pick it up, I just picked my finger off the mouse pointer, you will see that it dropped the block and put it back into its section. So grab hand, hold the mouse pointer down until it grabs the block. Anywhere in the block, you can click anywhere in this block to grab it. So here I am grabbing it, and I am now dragging it into the script window, and wow, we have our first block of code. What does it do? It does absolutely nothing, because all it does is tell us to begin running the code when the green flag is picked. So that's more like a signal than it is an instruction. Okay, so we will start all our programs with this green flag because we want to run the green flag when we want to activate the sprite only when the green flag is clicked. Okay, so first one done. All right, now I'm going to first introduce you to two areas that we're going to start using first while we program. We're going to use the motion because I know you all want to make things move, and we're going to do the looks because we all know looks are important, right? No, maybe, but looks will be able to change the appearance of the sprite. So those two things we can see straight away. They are visual things. We can see it moving and we can see it changing its appearance. So we'll write some code using these two things first. So the motion blocks are blue, and the looks blocks looks blocks are like mauve, because to me this is purple, right? The sound blocks are purple. So let's call this color mauve. So the motion blocks are blue and the looks blocks are mauve. Okay, so let's make this sprite move. Now if you look at this first block there, it says move 10 steps. So I'm going to grab this one, and again you can see I'm placing the pointer over the block, pressing the mouse down, holding it down until it grabs the block, and then drag it into the window. Okay, now this block is now in the window. Now let's talk about what we are seeing. You are seeing two blocks in the window, but they are separate blocks. It's like having your Lego pieces all just lying about on the table. They only mean something when you connect them together. Okay, so you will see that we have two blocks, and they are separate from each other. So how do we connect them? You simply, firstly, they must be able to fit. Now you will see these are basic blocks. This is not a complicated thing. And Lego is more complicated than this. They only have one basic shape that shows you whether they can fit. So you'll see that this, when the green flag is clicked, has a little indentation, kind of like a thing sticking out at the bottom there. And for the move block, it's hollow. And it seems like the hollow shape is exactly the same as this protruding shape there. So it shows that it can fit. Okay, so Trevor has got his hand raised. Okay, let's see what Trevor wants to do.
Hello, sir.
Hello, Trevor. You want
How
to
are
ask
you?
it? I'm good.
Yeah, I'm fine.
Okay.
So I want to ask a question.
Yeah.
I want to ask a question.
No problem.
Okay, so okay, for the robot, when you put to move 10 steps, and if you also put 15 degrees also, like, but if you change it from 15 like to minus 20 or something, would the robot move or like
Okay.
go up.
All right, Trevor. Okay, thank you for your question. Let me unmute you, and then I can answer the question for you. Okay. Right. Let's answer Trevor's question now. Firstly, you've gone a little bit ahead of us because you've gone to the next instructions, which required the robot to turn. Now, the robot turns in a 360-degree, exactly the way I showed you. If you look at this section out here, you'll see your directional arrow. So obviously this is 90 degrees. 15 degrees is somewhere around. Well, it's going to turn 15 degrees from where it is now. So that would be maybe just a smidgen down the road there. Okay. So obviously, if you do a 360-degree turn, the robot would go all the way around and face exactly where it's facing right now. This is always the 90-degree direction. In fact, you can see I messed it up a little bit, and I made it 90. Oh, let me just type that in. And it's 90 degrees. Okay, so yeah, so that's when we want to turn him, right? So thank you for the question, but don't worry. Again, if you want to experiment on your own, in fact, the best thing is to put the things there and put the numbers in there and see what it does, right? I will get to turning, but maybe not right now. Okay, right. Thank you, Trevor, for your question, and we're going to move on. Right, now I want to talk about connecting the blocks, right? So when you connect the blocks, you simply drag the blocks together. Now you see this little shaded area happening there. That happens when one block that is able to come close or connect to another block. When that can happen, then you'll get this little shaded area between the two blocks. I'm going to move. It's quite a large space. Can you see? If I move it too far down, then that shaded area goes. Now watch. I'm going to move it closer, 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 and you'll see the shaded area. As soon as you see that area, you can let the mouse go, and the blocks will automatically connect to each other. Okay, so you've got to practice that. Now I'm separating the blocks, and then I'm moving it. How am I moving it? Again, hold and drag. Keep the left mouse pointer down, and you got to hold it down and drag it. And then as soon as that shaded area comes up, the blocks will join. Okay, you followed that? Okay, now I can always take a block at the bottom and separate it, just like breaking up Lego pieces. Note what happens when I grab the top, though. Everything moves together, right? So I cannot take this top block out by clicking on it and then trying to pick it up off the bottom one. That will not work. If you want to separate these blocks, you've got to grab the bottom ones first, and that's how you separate them, right? So you got to remember that. Sometimes you'll find that you've put code together and it's not working, and you don't like the blocks, or it's not doing what you wanted to do, and you'll have to undo things, and it's quite terrible to have to restart and from scratch again. So it's better to just move these blocks around, and you can have lots of little blocks lying around on your screen. The blocks don't do anything. Only the ones that is part of this flag will happen when we click the flag. Okay, so here we go. Two things. Right, let's suppose move 10 steps was not the block that you wanted. You dragged in the wrong block and you don't want this block there. You simply drag it back into the window, right? Can you see what I did? Now it's in, hold, drag at any, and you don't have to go and put it exactly on top of where you found it. You simply have to cross this line here. Anyway, I can do it even at the bottom. Watch. I drag past the line, let go, and that move block is back in its place. So that's pretty nice and neat, right? You don't have to worry about putting it back in its correct place. The computer will handle that for you. Now let's put that move 10 steps back. Let's connect it, and let's see what happens. Oh, wait, I did this yesterday. We got as far as move 10 steps. And I remember I did say that the sprite moves 1 pixel at a time, which is 10 steps. Now I want everybody to now cast your eyes upon the X value at the bottom of the screen where my mouse is right now. It is showing you minus 149, right? Okay, now watch what happens when we press the flag now, because remember the flag is to run our code. So we press the flag and the sprite moves. It was minus 149, now it is minus 139, clearly showing that it's moved 10 steps. Let's click again. From minus 139, it should go to minus 129. Let's check that out. And that is correct, minus 129. Okay, now I'm going to put another block, move 10 steps, another 10 steps. Now what happens when I join these two and create two separate steps of move 10 steps? All right, so now we press the flag and we run the code. The robot jumped again, and now it jumped to, let's make it a nice number, like or let me put him on, let's put him on minus 100 to start with. Oops, get that back there. Right, let's put him on minus 200 to start with. That's there. Okay, so we can see in 20s, right? So let's click the flag and move 10 steps, and he was on minus 200, now he's on minus 180. So he has moved 20 steps. So that's correct, he's moved 20 steps, but let's watch him again. Click, minus 160. So he has moved 20 steps. Now I'm going to open the floor for questions again. What's kind of not nice about what we've seen? Anybody want to answer? How would we rather like those two instructions to be seen? Anybody want to speak? Raise your hand and I'll unmute you. No hands? Hey, come on. Talk to me, guys. Okay. Okay. Trevor, it's you again. Trevor is the only one who talks to me. Okay, I will.
Sir, is it true?
Yes.
Right. So tell me, why is there no walking animation?
Right. Very good question. Thank you, Trevor. I asked a question, and then Trevor asked me a question instead. So let me answer Trevor's question, though, even though, Trevor, you didn't answer mine. Why is there no walking animation? Because we have to do everything. If we want to animate the sprite, we have to do it. So it's a lot of hard work. You must, maybe now, after you do all this, you'll really appreciate all the hard work that goes into programming. Am I going to teach you how to animate it? Yes, I will. Okay, but that's not so easy. It takes a lot of effort, and I got to take you through one step at a time, right? Okay, now first, what I'm trying to get at here is we've got two move instructions, but when I press the flag, it's working because you can see from the X values that it is taking 20 steps, but it's doing the 20 steps in one, it's all just one movement. I don't really see the steps. And what if I put another one and another one and another one, and that's 40 steps, and I click on the flag. So it's moved 40, look at that, it's minus 90. And then if it's 40 steps, it's gonna go to minus 50. So it's moving 40 steps, but it's doing everything in one instruction. It's like I got 4 instructions, but it looks to me as if the robot is actually just following one instruction and moving 40 steps all in one hit. Okay, so now I'm going to bring back that word I taught you about. The word is called artificial intelligence. Okay, everything is controlled by us. We are really the brains behind how the sprite does. So we have to decide, we have to write instructions for every single thing that we want to do. If we wanted to make it look like it's taking steps, then we'll have to do that. So I'm going to, now watch how I break these. Can you see I got 4 move instructions there? I'm going to grab these last 2, and I'm just gonna throw them out for now. And I'm gonna take you to controls. Okay, now I'm going to ask a question. Right now, I know some of you got your hand, I know you got your hand raised, Trevor. Hold on for now. I just want to get through this thing, and then I'll take some questions just now. Okay, now there is a control which is what is this? This is like mustard. The controls are mustard colored controls. So there is one control here that I could put between these two move steps in actual fact, so to separate the steps. So my question to you is, can anyone tell me which control it would be? You can raise your hand. You can see my screen. It's showing you all the controls. It's one of them that you can see on the screen. You don't have to scroll down for any more. The one that I want is visible, and I just want to see if you can answer. Right, I've unmuted Scar.
You must use the repeat one.
The repeat one, to show that the instructions are two separate instructions. Okay, thank you, Scar. Actually, no, it is not that. Let's see if I don't know who.
Hello?
Hi, what is your name?
Novo.
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 Novo. Well, hello, how are you?
I'm
Which
fine,
one
and
of,
you?
I'm pretty good. Which one of those instructions do you think we could put between those move steps?
The first one.
The first one, well done, thank you. You can give yourself a clap. Okay, now let's do that. Let's grab a wait 1 second. Now, to introduce you to how sprites follow instructions. Sprites follow instructions one at a time, instantly. So move 10 steps and move another 10 steps. It does those two instructions instantly, so fast that your eye, your human eye, actually cannot see that the sprite is following two instructions. So this block here in the control block, right? So this is a control structure, will actually slow things down. This is going to slow the sprite down so that the human eye is able to see what it can do. Now, can you see? Let's read this instruction. It says, wait 1 second. So what it means is that we're going to delay an instruction by 1 second. And that's enough for us because we can count 1. And then that delay will be enough for us to see any difference on the screen, right? Now, I want to put this wait 1 second between these two move steps, okay? So I want to slot it in there. Now, there are two ways to do that. I can actually drag it in and, oh, sorry, no, I have to move this instruction out of the way because that's where I want the wait 1 second to go. And then you can put that one in there. You can see it fits in as a shape. And of course, and then we can now create 3 instructions we have now. So look, we've got a nice long script, guys. What do you think? 4 steps, click the flag, move 10 seconds, wait 1 second, move 10 steps. Okay, so now the sprite will follow. Remember, the flag is just to say when to begin. But now the sprite will follow 3 instructions. It will move 10 steps, wait 1 second, and then move another 10 steps. Now let's click our green flag to see how that looks. Okay, did you see that? Let's do it again. Now it actually, you could see the movement a little better. Okay, you could see the movement a little better. If you find that 1 second is too slow, right, now watch this. You can take your hand and where the 1 is, if you click in that window, you can now change that 1 to any value that you like. Even the 10 steps, you could change that too in the same way. So let's make it 2 seconds. And by doing, you just press the keyboard, number 2, and just click out of there to make sure that the 2 gets stored. And now let's look at our instructions. Move 10 steps, wait 2 seconds, and then move 10 steps. Now, remember, all this will run, excuse me, when the green flag is clicked. So let's press him. Oh, did you see that? Now you could see the movement a lot better because there is a longer pause as he is moving. Okay, he's not moving his legs and he's not moving his hand. I think Trevor was a bit upset about that. He's not so animated. He's just moving, right? But animation, we will get to. Don't you worry about that. Okay, now let's make him move a few more steps, and we want to grab a few more instructions and they're going to be the same instructions. Move 10 steps, wait 2 seconds. So watch what I do here. I grab this block out, okay, like that, because I'm going to copy it. Now watch how you copy this block. Okay, now again, you might want to make some notes here because I'm going to teach you a shortcut. Instead of doing this, now you could do this. You could drag another weight, and then you're going to go up. Can you see that's irritating? And then I'm going to drag another move, and we're going to make it move some more steps. Right? I'm going to get rid of those 2 instructions. Watch how I can get rid of an entire block of instructions in one hit. Gone. Right, I want to take these 2 and I want to copy them. Make a copy. Now watch what we do. Before you copy, make sure that your hand is on the block that you're going to start copying. If I put the hand there, it'll only copy this blue block. So I'm going to put the hand there. And then, so step 1, put the hand on the block that starts the sequence of blocks that you want to copy. Step 2, right click on the mouse. Okay, so it's not the left mouse pointer, it's the right click on the mouse. And you will see the first shortcut option called duplicate. Click duplicate, and look what happens. Now you have 2 copies of this instruction, and you join them together, and you can see what if you're a little bit fiddly with the mouse, with a little bit of practice, you can see you can join these things up, and you can break them up as easily as you can any time you want to. Okay, I've got Donald who's raising his hand. Let's see what Donald wants to say. Hey, Donald,
So,
how are you?
Good, thank you. My real name is Fortunate, but by the way, what I was saying is that can't we use the repeat block instead of like doing the whole blocks again?
Okay, so have you programmed before?
Yes.
Okay, right. Firstly, okay, I'm gonna unmute you now. Okay, so your name is showing up as Donald, but oh, I think maybe you're probably using your father's computer. She says her name is Fortunate. Firstly, well done, Fortunate. I must congratulate you. You've got some experience in programming. And one of the control structures that we can use to repeat instructions is something called a repeat loop. Okay. Now, unfortunately, Fortunate, you are a little bit ahead of everybody else. And we're going to actually go in that direction, where we're going to teach people how to repeat blocks of code into a repeat loop or a repeat structure. But we don't want to do that straight away for people who have never seen programming at all. For some people in this room, this might just be the first time that they are ever seeing this kind of block-based programming. So as teachers, we were asked to assume that people haven't programmed before. But thank you for your question. And now let's run these instructions, and let's click the green flag. That's 10 steps, and another 10 steps, and it takes another 10 steps. Look at that. That's pretty cool. Okay, now let's make more blocks. This time, duplicate all 4. Look at that. Make more moves, and click there. And now let's look at our sprite. And he moves a lot now, isn't it? Okay. And let's just maybe do 6 more. Let's duplicate that. Fortunate is very correct. You can see now our program is looking very long. Can you see? Look at this code. And you're just doing the same thing over and over and over again. Okay. So we're just watching the sprite move. But it's pretty cool. He's following your instructions. Let's drop this to, I just want to show you that you can also use decimal values. So if I don't want, it's also, you notice that when you click the gram hand in the wrong place, it actually runs your code. Okay. So I want to change all these 2s to 1.5. I want him to walk a little bit faster. Okay, so bear with me. Now, Fortunate brought up a very important point. If you are using a repeat structure, which I will teach you to use, You won't have to be doing this irritating thing that I'm doing now, where I have to change it to 1.5 in all the code, because we can just simply repeat those instructions. Now, we got him taking a lot of steps here now, and let's press the green flag, and he's walking a little faster than 2 seconds. And here he is, he's just going for it. Go, 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 guy. Okay, so here he is, and that's the sprite moving along according to your move instructions that you have given him. All right, I'm gonna move to the next thing that Trevor was talking about now, right? And we're gonna quickly see how we can animate this this sprite, and I'm going to show you how to do that. Now, let's look at this block here at the top where we've got code, and I told you yesterday that there is a second tab called costumes. Right now, if you want to animate your sprite, and here's where it's going to be very hard work, and you're going to have to fiddle, and I'm sure you guys will enjoy it, maybe because it's another kind of artwork altogether. But if you want to animate your sprite as he's moving, you will actually have to, again, fool the eye. Remember, everybody, this is artificial intelligence. It's not really moving at all. It's simply following instructions. And how we do animation is we simply, well, there are lots of ways to do it, but in Zora blocks, the way we do it is by simply changing costumes. And it's much the same as back in the old days where they would draw a number of pictures. You can draw pictures on your on different pages, but draw the character in different positions, and then you flip the pages pretty fast, and it would look like the character is moving. That was how animation was first done, and that's how we're going to do it here in Zora. Now, let's first have a look at the two costumes that we've got. You'll see costume 1, and then there's this costume 2. Okay, so this is the second costume. You can see he's now turned around and he's saying hello, right? So costume 1, costume 2. Now let's go back to the code, okay, and let's make him move, and then at the end we'll make him turn around and say hello like this, and watch how we achieve that. Now remember, I want to break the block up here. Okay, and I'm going to take you to looks. Remember, I said we will use motion and we will use looks in our first lesson. You will see there is a block here that says switch costumes. Okay, so now you can see, because we clicked on the other costume, he is now, facing this way. So let's go back to costumes and select costume 1. So he's kind of like in the right position, right? And then let's go back to 2. Okay, and then we will just drag at the end of this move code, we'll say switch to costume number 2. Now remember the numbers. Let's go back again. Costume 1, costume 2, right? So you've got to keep track of your costumes. You can name them as well if you like to. Okay, so, but we won't do that right now. And so here's all our instructions. We're saying move, and then right at the end, he switches costumes. Now let's run this code by pressing the green flag and see what happens. So there he is, he's on the move. He's moving 10 steps in intervals of 1.5 seconds. And at the end, he does that. So it kind of looks like the robot suddenly turned around at the end of walking and is saying hello to all of you. But really, he hasn't done that. All we have done is that we have switched his costume. Okay, now he's in that direction. Okay, and then you have to go back there and put him back into position 1. But another way of doing that is to include that other costume right at the beginning. So one of the things you could do is to make sure that if he ends, if the sprite, and I'm not going to say robot, if the sprite ends his position in a different costume, and you run the program again, he'll run the program using the same costume. In fact, let's take this block out and just rerun the program. Now notice how I also wanted to show you, can you see you can have blocks that are hanging about on your script area, but they are not part of the program code because it's not it's not attached to anything. So let's see if we run the code now. So can you see he's moving, but now he just looks silly. He's just moving sideways. And in the end, he's supposed to turn around and say hello to you, but he won't be able to do that because he's already doing that. So when a sprite ends in a costume, that is not really how it's supposed to be when the program starts running from the beginning again, the best thing to do is to set the sprite in the costume, begin the entire program in the costume that you want it to be in. And of course, that was costume 1. So how do we switch the costume? You'll see there's an arrow here, and you click the arrow, and then you select your costume, and now he's on costume 1. This block is not joined to the rest of them, so we've got to join it up. Now we've got a long program here, and the sprite will move. Now, can you see that the sprite is in his Hello Kids kind of costume? So when we click the flag, because out here, we are asking him to switch his costume to costume 1, which is his walking costume. He's going to do that straight away before he follows any move instructions. Okay, shall we change these all to 1? Maybe it's taking too long to move. So let's just go to 1 second. Okay, that's all of them. And let's start the code now. So can you see? He started by switching himself to his walking position. And then in the end, he stops to say hello. And he ends in that way. And when you start the program again, he walks in the proper kind of walking position again. And then he waves hello to you. Well, look at that. Okay. One other thing that we could do, if we don't want him to remain in his hello position, is we could change his costume at the end as well. That's an alternative thing that we could do. Now, I'm going to do one more thing before we run out of time. If you press the flag again, you'll see that he starts walking also from where he left off. So we will get to a point, if we keep running this program, the poor guy is going to end up off the screen, and we're going to have to keep moving him to the left so that when we start running our program, he starts in the correct place. And now you notice we didn't even get him in the right place. We can't even quite see his legs. So let's press the start, and you can see him walking. I just want to demonstrate the stop button. Can you see? As soon as you press the stop, the entire code runs. We realize, look, we don't want to wait for the whole thing to finish now. He's in the wrong place. His legs are not right. Okay, so we can't see his legs. So here's a cool thing that you could do. All right, move the sprite to where you want him to be, and check the coordinates, the X and Y coordinates. Okay, let's maybe you want him to be in the middle of the screen here. Right, can you see it's minus 223 and 120 X and Y values. That's his X position, that's his Y position, right? And if you go to the motion blocks, and this is the last block that I'm going to demonstrate to you today as well. I think I'm giving you quite a lot to fiddle and experiment with before tomorrow's lesson, but I also don't want to give you too much so that you get confused before tomorrow comes. Okay, so you can see there is a special block called go-to X and Y, in which you can send him specifically to two blocks. And what blocks are kept in there? Excuse me, exactly where he is now. So that's pretty cool. You can switch his costume and then send him to the starting position that you want him to be at, and that's gone. Now you'll notice that even if you move the sprite around, you can see in the motion blocks, the blocks keep track of where he is. Can you see he's now at 44, 219. Let's look at our sprite's position, 44, 219, right? All these blocks are showing where he currently is. But the one that you put in your programming languages, you preset it in your script to be minus 223 and 120, and you want him to always start there. So even though he's gone, let's stick him right there in the corner. Oh, we can't even see him. He's gone to the corner of the screen now. But let's run the program and see what happens. Can you see that? So that go-to instruction is pretty cool. You can send him, and I know you're now very excited. I can just hear you all screaming in the background there. You're very excited with that one. You now realize that you can send your sprite to any part of the screen that you want to. Let's run the program again. He's in a different position, but can you see now that he's always going to walk from that same position when the program starts running? And he's moving along now, and he stops to say hello to all of us. Okay, so yes, that's motion. Now let's have a look at the blocks we have combined. We are using blocks from three different sections. We're using motion blocks, which are the blue ones. We are using the looks blocks, which are the mauve ones. And we are using one event, and we are using blocks from the control, which is mustard. So in actual fact, we are now combining blocks from 4 different programming sections. So well done to you for the first day. I hope that wasn't too much. I think it's not too difficult. And you can experiment with these few things as we go along. I want to just finally, before we close up, is I want to show you how to save something. Right? Now remember, you are working online. Ms. Zora is a 0-rated online application which you are using in your browser. So this program code at the moment, this code, here's what we call coding. So here's your coding, here's your robot, and already on the 3rd day, you are giving instructions to a robot out here on the side. So coding and robotics is quite real. All we've got to do is get somebody in a factory to put our code together, and then it gets machined in a factory onto a microchip. And once it's on the microchip, the robot can follow the instructions in a different way from a controller. Now, this is what we call a program in its design phase, because we are using software to design it. People who use the robot are not supposed to see all your instructions. This is for us. We keep fiddling and working and testing, and when we're happy and the robot is working perfectly, then we take this program and we put it onto a microchip, and then after that it goes into a remote control. Okay, so quickly before time runs out, I want to show you how to save this code. Now, very easy. You just go to File, okay, and you'll see an option there that says Save to your computer. So even though you are on an online platform, you're using your browser to write this code, you can still save your code to your computer if you want to. Before you go there, you see this block here that I've highlighted now. It says New Project. That is where you would want to give the name for your project. Remember, the whole program altogether is called a project. So we're going to delete New Project, and let's call it Robot Walk. Okay. Now I want to teach you a naming structure. You will see that when I give programs names, I use English and words that I can understand, so that when I see this program in a list of files, the title tells me what it's going to do. Like I said yesterday, if you just call it Robot 1, Robot 2, Robot 3, later on you'll have all the programs in your computer called Robot, this, that, and whatever. And when you try to remember which is what, you're going to just keep opening one file at a time, trying to look for the one that you want. So don't be lazy. I know you're very excited and you want to write code, but be patient with yourself and make sure you name things properly. So Robot Walk, it's 2 words. Notice that I used a capital R for the first word and capital W for the second word. That is a programming naming technique called camel case. The capital letters are like the humps of a camel. So this camel's got 2 humps. It's 2 words, capital R, capital W. Why do we do that? Because it's much easier to read. Can you look at that? That's harder to read as a word than if the W was capital, as a sentence, sorry. So Robot Walk, and that's just a naming structure that I want you to adapt and use when you are naming your programs. Okay, now the naming process, click on File, click on Save to your computer. and your file is saved. Where is it saved? It would save in your downloads folder. So you probably would have to go to your downloads folder. I'm going to go there. My computer is a bit slow. Okay, that's my Explorer. Just going to click on downloads. And like you can see on the screen here, robot walk. Okay, so that's the name of the file. And it has been successfully saved. Okay, and that brings us to 2 minutes left. I will just maybe take a couple of questions in the 2 minutes that we got left before I close the session and log off from Zoom. Anybody want to ask anything? We might be able to just take one question.
So,
And that is my man Trevor. And we've got Fortunate. Okay, let's unmute Fortunate because Trevor has spoken before.
Sir,
Yes, hello Fortunate.
while I was coding, my motion blocks just disappeared. I don't understand what's going on here.
What do you mean by your motion blocks disappeared? They should be on the left of the screen. If you're looking at my screen, you should be able to see them all there.
Yes, but then mine was like stage selected, no motion blocks.
So you got none of this, what you're seeing here. Okay.
I was coding, I could motion blocks, but then I don't know what happened.
Oh, you lost it.
Yes.
Okay. I don't know why it would disappear. Okay, what I will do, what you can do for now is close your browser and reopen it and go back into MS-Word and it should be fine. And I will experiment after this class to see if we can take blocks off and on and then tell you how, if you maybe accidentally removed a set of blocks and inadvertently removed it, and I'll tell you how to put it back. At the moment, I'm not sure if you can do that. Okay, so with that, I want to close the class. I want to thank you once again for joining us on this channel with Africa Teen Geeks and the Department of Education. I'm your facilitator, Mr. A.F. Gabriel. We've done well today. We've actually made a robot move with some instructions. And tomorrow, we will cover a little bit about what Trevor asked us today with regards to how we can animate it and make him look like, maybe we'll make him swing his hands and move his legs as he's walking. So we'll do that tomorrow. So I know you're excited to get going with that. Have a good afternoon, all of you. And I look forward to seeing you again tomorrow at 1 o'clock. Goodbye, everybody.